Welcome back, all the teachers and students. I have started a series of physics examination where I'm discussing about important 5 marks numericals. Previously, one more video was uploaded. Link is in the description. You can check out that. So in this series, my focus is to make the numericals easy because I have seen a lot of students who have a list of important questions with them, but they always ask what are the important numericals. So most of them will lose a lot of marks in the numericals. So as I told in the previous videos, make a formula list and you will almost get a direct formula based questions. And let us get into this particular question. Now this is 5 marks important numerical. Let me read the question for you all. As you can see, there are two capacitors. So let me draw two capacitors. So capacitor is a simple device which is used to store the charge. Let me name the first capacitor as C1 and second one as C2. The values of these capacitance are 600 picofarad and 900 picofarad. So as we know, SI unit of capacitance is farad. Now pico is a prefix which is used here. So let us convert that into SI unit. So 600 can be written as 6 into 2, 10 power 2, and pico, farad. If you want to convert to farad, you need to multiply with 10 raised to minus 12. Like how for milli we have 10 power minus 3, for micro 10 power minus 6, and for nano 10 power minus 9. Similarly, for pico we have a prefix to convert to SI unit as a 10 power minus 12. And another capacitance value is 900 picofarad. Since they are connected in series, so this is how one after the another you need to connect in series. Now 900 can be written as 9 into 10 power 2 and pico is 10 power minus 12. So if you solve these further, 2 minus 12 minus 10 and C2 is also 10 power minus 10 farad. Now they are connected across 200 volt supply. So these capacitors are connected across a battery whose potential is given as 200 volt. So the value of V is given as 200 volt. Majority of the numbers, if you convert to 10 powers, your further calculations will be easy. So this is the overall given data. Now, three sub questions are asked. So I will write what is my target. First one, effective capacitance of the combination. So only two capacitors are there which are in series. So effective capacitance of the combination. So just for reference, let me take these 2 points as A and B so that I can write it as C effective or C of AB. Then in the second part, they have asked potential difference across each capacitor. So obviously two capacitors are there, they are in series. As per concept, whenever capacitors are in series, charge is constant. So the parameter which varies is a potential. So two capacitors, across each potential difference is asked. So obviously they are expecting the value of V1 and V2. Then in third sub question, they want us to find out the total charge stored in the system. This is very important word here, system. System is nothing but entire circuit. So overall charge, they are not asking the individual charge. Overall charge is nothing but a total charge in the system. Now, after writing given data and converting into SI unit and after analyzing what exactly is my target, then now let us think about the concept which will be implemented to this particular diagram. Two capacitors in series, effective capacitance I want, direct formula based question. So capacitors in series, see, resistors in series is sum of them R1 plus R2, whereas capacitors in series for 2, shortcut is product of capacitance divided by sum of capacitors. After that, put the value, get the answer. Now, let us get into this. C1 is 6 into 10 power minus 10 into C2 is 9 into 10 power minus 10 divided by C1 plus C2. Yeah, since I am adding them, I can take 10 power minus 10 common. So 6 plus 9 is remaining in bracket. 6 nines are 54. 10 power minus 10, 10 power minus 10 is 10 power minus 20. 6 plus 9 is 15, minus 10 as it is. So 54 divided by 15 into, take this minus 10 from denominator to numerator, so it will become plus 10. So 10 powers will be minus 20 plus 10, which is 10 power minus 10. Comfortably, you can find out this ratio. PU board calculator is also allowed, whereas in majority of the boards, ICSC boards and all, calculator is not allowed. So 54 divided by 15, if I do, all I get is 3.6 into 10 power minus 10 farad. This is the effective capacitance between the 2 points A and B, which I have taken for reference. Now, V1 and V2, potential across each of them. Total potential is 200 volt and V1 and V2. So one hint here is, after finding V1 and V2, if you add, you should not get the answer more than 200 volt. See, supply itself is 200 volt. So obviously V1 and V2 has to be less than that. Suppose if you have a 500 rupees, if somebody is asking you 1000 rupees, you have 500 rupees. How do you even give them 1000 rupees? So in a similar way, the value of V1 and V2, if you add after finding, your answer should not exceed 200 volt. So these are all small techniques which we need to implement to verify whether we are doing the correct calculation or not. And always in numericals, there is always a high possibility of getting out of, provided if you are following all the steps. Whereas in derivations and theory part, if you miss here and there some small lines, some small step, there is always a possibility of reduction of marks. Whereas in numericals, you get the exact answer, you will get the exact 5 marks for each numerical. So now let me find out potential across each capacitor. So the basic concept of capacitance is charge by potential. So in series, let us get back to the concept again. In series, when two capacitors are connected, charge flowing through them is same, whereas potential will be different. So C1 V1 will become, whereas in C2 it will be Q by V2. So clearly you can see I am not modifying charges Q1 and Q2. The simple reason being, charge flowing through them is absolutely constant. So modify this. The value of V1 will be Q by C1 and V2 will be Q by C2. Now the question arises, I don't have a charge. If you look at data, there is no charge given. That means I have to get back to the third sub-question. First find third sub-question, get the value of Q and substitute back here. So again, the concept of capacitance I will use, which is, so if I am considering total capacitance, I need to take the total charge divided by total potential. Total capacitance, just now I found out 3.6 into 10 power minus 10, and Q is nothing but total charge. So capital Q also you can consider in this case, and potential is 200 volt. As you can clearly see here, supply is 200 volt. So 200 is 2 into 10 power 2. So therefore charge are required. So just cross multiply 3.6 into 2, 7.2. Now see, whenever you cross multiply, the sign of 10 power will not change. So if you just cross multiply, it will be 10 power 2 as well as, which get multiplied with 10 power minus 10. So minus 10 plus 2 is minus 8. And put the SI unit of charge, which is coulomb. So I got the answer for sub question 3. Now let us get back to find out potential V1. V1 is Q by C1. Similarly, V2 is Q by C2. Charge is same, so I am not writing it as Q1 and Q2. If you write Q1 and Q2, that absolutely shows that you are not firm with the concepts. In series, capacitance across capacitor, charge remains same. The way across resistor, current remains same, across capacitor, charge remains same. So Q value just now I found out 7.2 into 10 power minus 8 divided by, the value of C1 is this much. Converted value into SI unit I will take. I can't take the given data. See, I have done so much conversion here, so much of effort. Then again, if you take back again 600 without considering the conversion into SI unit, your entire effort will be wasted. Okay, so I will solve this. V2 charge is same, and C2 value, as you can see, 9 into 10 power minus 10. So all you need to do is divide them to get the value of V1 and V2, which gives us potential across V1 and V2. So I have made a box, complete makeup is done. Now all I need to do is divide the numbers. 7.2 divided by 6, which will yield as 1.2. Minus 10 take to numerator, it will become plus 10. So minus 8 plus 10 is 10 power 2, which is 100. You can keep the answer as it is, or maybe you can further simplify. So 10 square is 100. So 100 into 1.2 if you do, you will get 120 volt. And V2, so 10 power will be again 2. So 7.2 divided by 9. Denominator is greater than numerator. So obviously we'll end up with answer less than 1, which is 0.8. So 0.8 into again 100 if I do, all I'm going to get is 80 volt. So exactly if you add V1 and V2, you will get a total voltage which is 120 plus 80 as 200 volt. So this confirms that our answer is correct, because the total supply which was supplied across a capacitor is also 200 volt. So thank you all. In the upcoming videos, again, I will try my level best to give you the quality content where most important 5 marks numericals will be again discussed. I have already started the series, so you can expect few more videos. So before watching any video, always take a pen and paper, pause the video initially in case if you know the question already. So try to solve, then we can verify with the answer. Thank you all.